Hello student, today we will start transpose of a matrix. So what is a transpose of a matrix? It's a very simple concept. Transpose means if you consider a matrix, any matrix is given, suppose, just you interchange the rows and columns. Then you will get a new matrix and that matrix is called the transpose of the given matrix. So here you see what is the transpose of a matrix. The matrix obtained by interchanging the rows and the columns of a matrix A is called the transpose of A, and it is denoted by A dash or by AT or by A to the power small t. So how to get a transpose of a matrix? Just you see, you have suppose first row, you make the first row as, write down the first row as first column. Similarly, suppose you have second row, you write it as second column, and so on. In that case, you have a new matrix and that matrix is called the transpose of the given matrix. Okay. And here you see, if A is a m by n matrix, then A transpose is a n by m matrix. Because you see row and columns are interchanged, so obviously their order will be interchanged. And again, ith element of A is equal to jith element of A transpose. I'll give you an example, it will be clear to you. Suppose you consider this matrix A. A is 1, 2, 3, 4, 5, 6. It's a simple matrix I have considered. What is the order of this matrix? Number of row is 2 and number of column 1, 2, 3. So 2 by 3 matrix. Now, by definition of the transpose of the matrix, what you have to do? You have to make the first column or write the first column, row as the first column. That means this 1, 2, 3. It's horizontally, you make it vertical. 1, 2, 3. It becomes first column. Then second row you write down as second column. Then you get a new matrix and that is the transpose of this given matrix A. Now see the order. How many rows are there? 1, 2, 3. So 3 column is 2. So it's a matrix of order 2 by 3. So hope you understand how to get the transpose. Interchange the rows and the columns. The order will be changed. Now you see here, from here only we can say that ith element of A is jith element of A transpose. Suppose you consider 1 position will be not clear you. So ekarone moi dhora tumalok 1 2 position dhorilu. 1 2 position of A is 2. Then it will be 2 1 position of A transpose. 1 2 change I and J. 2 1 is not a 2 1 position same. Say 1 3 3 2 3 1, it's 3, right? Suppose 2 2 2 2 you say here also same 2 2. Is not it? So ith element of A will be equal to jith element of A transpose. So this is the transpose of the matrix. And in the transpose, in case of transpose, one more thing we can notice here, that is if I take the transpose of the transpose, then tomaloke jodi A transpose matrix took ako transpose lua. This is your matrix, transpose matrix. You are taking transpose of this transpose. Then it become what? First row is 1 4, it is written as first column. Second row 2 5, this is second column. Third row 3 6, you have to write it as third column. Then you will have a new matrix and you see compare it with the C. This is nothing but your A. So transpose of the transpose is the original matrix. And one as a note you remember, inverse identity matrix, transpose of identity matrix is remains as it is. Tumalke identity matrix or jodi transpose lua change na hoy. Hobo. Etia ami next now symmetric matrix. What is a symmetric matrix? So to define a symmetric matrix, it is related with transpose. You have to consider a square matrix. Remember that. A square matrix A is said to be symmetric if A transpose equal to A. And jodi tumalkor transpose not as a notun matrix poa. Hey transpose 2 or hey matrix 2 or jodi original matrix 2 eke hoy, then that matrix is said to be symmetric. And in this case, you must have a square matrix. Obviously otherwise not, because otherwise ki hobo tomar kaje rectangular matrix lua. Suppose it's a matrix of order 2 by 3 A. In that case A transpose will be a matrix of order 3 by 2. So obviously they will be not equal. So symmetric cases will not arise there. So to be a symmetric matrix, you have to consider what? It's a square matrix. So in case of symmetric matrix, if Aij is a symmetric matrix, then always you will have what? Aij element is equal to Aji element of A. I'll give an example, it will be more clear to you. Here you see, Suppose I have considered a matrix 4, 7, 7, 6. Here ij element is what? 1 to position element is 7. 2, 1 position is also 7. Now that means this is symmetric. Now if I take its transpose, 4, 7, 7, 6 is transpose. 4, 7 become 4, 7 column. 7, 6 becomes 7, 6 column. Is not it same with A? So A transpose equal to A. That's why A is said to be symmetric. Hope you understand? Symmetric hobo lagile ki hobo lagibo? Tumalkor transpose jitu lo matrix or original matrix to value to eke hobo lagibo. Now we'll have a new matrix, that is your skew symmetric matrix. Here also you have to consider a square matrix. A square matrix A is said to be skew symmetric if transpose of the matrix is equal to negative of the matrix. Symmetric hobo lagile eke hobo lagibo, kintu skew symmetric hobo lagile negative or logot eke hobo lagibo. So here I am considering an example 0, 3, minus 5, minus 3, 0, 1, 5, minus 1, 0. Take its transpose. What is the first row become? First column 0, 3, 5. Second row minus 3, 0, 1, minus 3, 0, 1. Third row minus 5. 5 minus 1, 0, 5 minus 1, 0. Now in this case you see A transpose and A, they are not equal. 0, 0 is okay, but this is not equal to this one. Similarly, but if I take the negative of A, minus and multiply korasun ki paba 0 minus 3 5 3 0 minus 1 this one. Here if I multiply it by minus 1 minus 5 1 0 minus 5 1 0. Now compare these two 0 0 3 3 5 5 minus 3 and so on. So A transpose equal to minus of A. Therefore we can say that A is skew symmetric. And in case of skew symmetric matrix we have seen Ij is equal to Ji. But in case of skew symmetric matrix, Ij is equal to minus Aj. For example, suppose 1, 2 position you take here. 3. 1, 2 position. 2, 1 position is minus 3. 1, 3 position is minus 5. This is what? 5. Have you noticed the diagonal element? All must be equal to 0. I'll show you, just see. In case of skew symmetric matrix, always we'll have what? Aij is equal to minus Aj. This is a very important thing. Okay? Remember it. Now you see, if I take I is equal to J, Aij become what? Ai is equal to minus Aj become minus Ai. If I bring this Ai to the left side, Ai plus Ai is equal to 0, which gives you 2 Ai equal to 0, that is Ai equal to 0. What does it mean? What does Ai mean? Ai mean they are nothing but the suffixes are same. Ki hoy etia? Diagonal elements. So diagonal elements of a skew symmetric matrix is equal to 0. So here you see. Have you noticed it? Diagonal element ebu nohoy janu 1 1 2 2 3 3 position here hoday 0 hoboi lagibo. Always diagonal element will be equal to 0. This is an important thing. Now we will discuss some properties of transpose symmetric and skew symmetric matrices. Without proof I am giving some results. For any matrix A and B, A plus B whole transpose equal to A transpose plus B transpose. That means sum of the transpose, and if I take transpose then take the sum, the results are same. Similarly, transpose of the transpose equal to A. We have already verified that. Scalar multiplication of the transpose is multiplication of the transpose with the scalar. But in the case of product AB whole transpose, the position will be changed, that is B transpose A transpose. A to kintu mon koriba ha ulta hoi jay. B transpose A transpose. And there are some properties of symmetric and skew symmetric matrices are also there. We have to do the proof of that. Sometimes they set in exam. For any square matrix A plus A transpose is symmetric. So we have to show it now that is a square matrix A plus A transpose is symmetric. So when we call the matrices are symmetric, if transpose of the matrix equal to the matrix itself. So I'll give a name of the matrix as P say. Then I'll check what is the value of P transpose. I took my P bili naam dilolu. Then I'll take what is P transpose. That is P transpose means what? A plus A transpose whole transpose. Then by this law, you know, A plus B whole transpose can be written as A transpose B transpose. So by that law, it can be written as A transpose plus A transpose whole transpose. A transpose keep as it is. Transpose of the transpose equal to A. Then you can change the position A plus A transpose, and which is nothing but P. So what does it mean? P transpose equal to P. It means the transpose of the matrix equal to the matrix itself, the matrix is said to be symmetric. That is, A plus A transpose is symmetric. One more property is there for skew symmetric matrix. For any square matrix A minus A transpose is always skew symmetric. So again, as earlier, we are naming it as, say, X. Jikun naam dibo par. Transpose what is transpose? A minus A transpose whole transpose. It will be equal to A transpose minus A transpose whole transpose. Like addition, it also satisfies, difference also satisfies the same condition. A transpose whole transpose is A. I need A in the first position, so I just write down it as minus A plus I transpose. Again, minus sign, if I take common, it become what? A minus A transpose. And A minus A transpose is nothing but your X. You see, this is your X. So here I am putting X. So what we have got? X transpose equal to minus X. What does it mean? That is nothing but the definition of skew symmetric matrix. Therefore, X is skew symmetric. And X means what? A minus A transpose is skew symmetric. So remember it, that sum of the matrix which is transpose is symmetric, and difference of the matrix, any square matrix which is transpose is always skew symmetric. So from here we can derive one more result, that is what? Any square matrix A is expressible as a sum of symmetric and a skew symmetric matrix. Jikono matrix. Tumi ki korba para, you can break up it as a sum of a symmetric and a skew symmetric matrix. Like this. You know A plus A transpose is symmetric, so obviously half of A plus A transpose will be symmetric. Similarly, just we have proof A minus A transpose is skew symmetric. Proof to tumalke koribo khujle agorita combine kori dile hol. This is skew symmetric, we can show it. So obviously half of A minus A transpose is skew symmetric. So we have got, this is a symmetric matrix, this is skew symmetric. Sum is this, and calculate it, open the bracket, half of A plus half of A transpose, half of A minus half of A transpose. A transpose, half of A transpose cancel out, half of A plus half of A will be equal to A. So every matrix, square matrix, can be expressed as a sum of a symmetric and a skew symmetric matrix. So this is all about the concept of transpose, symmetric and skew symmetrics. Next video I will give you the solutions of exercise 3.3. Thank you.